Hello. In this video, I'm going to talk about pH in the body. So first, what is pH? pH is the concentration of acid and base. So pH scale between 0 and 14, where each number represents a tenfold difference in concentration. So the concentrations of acids and bases affect chemical reactions in living organisms. So throughout the body, our different fluids and tissues need to have very specific pHs in each of those different places to be able to perform whatever functions that they need to be able to perform. So when that pH gets to be too high or too low in any of those different places, then we start to have dysfunction, disease, and even death. So one of the many things that we're regulating when we talk about homeostasis. So pH of the many different places in the body are critical. So pH is shorthand for the concentration of hydrogen ions in a substance. So it's really just how many hydrogen ions per unit do we have in this liquid or tissue. So the number in pH is based on the number of decimal places in the concentration. So if the concentration has 2 decimal places, like 0.01, then it's a 2 pH. If it has 9 decimal places, like I typed there, then that's a 9 pH. So we're on a scale between 0 and 14, where 7 is neutral, less than 7 is acidic, and more than 7 is basic. Okay, so it's a little bit counterintuitive, but lower pH means higher acidity. Higher pH means lower acidity. Okay, so higher hydrogen ion concentration is going to be a lower pH. So if we look at our little table here, all the way down at the bottom with a 1 that has no decimal places, that is the most acidic we can get. So we have a very, very high concentration of hydrogen ions. Okay, then as the concentration is less and less and less, and we start going over to decimal places, then we get more and more basic until we get to 14 decimal places, and that would be a 14 pH, which is the most basic, the lowest acidic. Okay, so this is another really great graphic that gives us an idea of what things like household items fall on this scale. So we can go from a pH of 0 on the left, where it's the most acidic. And as we move over, we see gastric juice is at a 2, apple juice at a 3, tomato juice at a 4.2, cabbage 5.3, cow's milk. Well, now we're getting closer to neutral being at 7, where we have distilled water is a 7, pure water is a total neutral. And then human blood is just a little bit on the basic side of neutral. Egg whites at an 8, sodium bicarbonate at 8.4, milk of magnesia at 10.5, and household ammonia at 11.5. So I want to point out that although we think of acids as being harmful, like we all know the effects that an acid could have, that it's burning, singeing, acid, but something that's in the other extreme can be equally damaging if it's not supposed to be that basic. So like, for example, Drano and other household chemicals that are similar, they have dissolving effects, and they're very basic. So although we intuitively know that very acidic things can be damaging, so can very basic things. So most of the body is kind of somewhere in the middle toward more of the neutral range, plus or minus a little bit, depending on what we need that to do. But there are some things that are much more acidic, like gastric juice, and other things that are much more basic, like some of the fluids in semen, for example, need to be more basic because they need to be able to neutralize the acidic environment in the vagina, which is important for conception. All right, so blood pH. Healthy normal blood pH has a pH between 7.35 and 7.45. So very narrow range where we want to always stay to avoid acidosis or alkalosis. So acidosis would be when we get our pH a little bit lower than that, so 7 to 7.3, much lower than that, and it's most likely death at that point. But when we're at 7 to 7.3, the person will start to feel disoriented and have fatigue. And acidosis could be caused by a variety of different things, but like vomiting of alkaline intestinal contents, diabetes, lung disease like COPD. So I want to touch on that for just a minute. Part of what puts more hydrogen ions into our blood is an accumulation of carbon dioxide. So carbon dioxide, when it mixes with our watery environment in the blood, there are chemical reactions that go on that I'm not going to get into here. But one of the byproducts of those chemical reactions is hydrogen ions. So the more carbon dioxide that dissolves into the blood, the more hydrogen ions that we have in the blood. And more hydrogen ions means more acidity. It means a lower pH. So for the most part, I mean, that's happening all day long, but for the most part, we use buffers and we exhale our carbon dioxide effectively, and we're able to keep our pH in our normal healthy range. But anything that interferes with our ability to clear carbon dioxide, which would essentially be lung diseases like COPD, where we have a hard time clearing carbon dioxide efficiently, and so it'll start to accumulate, and that means accumulation of hydrogen ions in the blood. So that's why lung disease like COPD can cause acidosis. And so a lot of the symptoms that are experienced by a person with COPD are related to the acidosis that they're experiencing from not being able to clear their carbon dioxide efficiently. Then alkalosis is the opposite problem, where we have a pH between 7.5 to 7.8. Again, above that, and most likely it will cause death. But within that range, alkalosis includes like dizziness and agitation. And it can be caused by high altitude breathing for the exact opposite reason that COPD causes acidosis. So high altitude breathing will cause alkalosis for the exact opposite reason. So in that case, we don't have enough carbon dioxide accumulating in the blood, and so then our pH will get too high. So it can also be caused by vomiting of acidic stomach contents, high fever, or taking antacids. So I mentioned that in both cases, acidosis and alkalosis can result in death if we get too far out of our homeostatic range. But they go two different routes. Like with acidosis, in earlier stages, it's disorientation and fatigue, and then as they become more extreme, can lead to coma and then ultimately death, versus alkalosis is the opposite. It has nervous system effects where you go into dizziness, agitation, eventually seizures, and then death. So in acidosis, it's more of a suppressive effect on the nervous system, and in alkalosis, it's more of an excitation sort of effect on the nervous system. Okay, that is all I have for you in this video. Thank you for watching.